All right, let's do this. Yesterday, we introduced the Sphinx and the Statue of Liberty, and you were going to be on a committee that was going to decide which one of those two monuments was most at danger of getting run down from nature, and which one we should decide needs to be fixed first. I asked you in this first big box here to write down which one you chose and why. I do want to remind you, if you forgot, that we weren't focusing in on the whole Statue of Liberty. I really was only having you talk about the base of the Statue of Liberty. Remember, that one cost more than the actual statue itself. So here's what I want you to do. Raise your hand if you picked the Sphinx as your one you thought should be repaired sooner. Okay, so 1, 2, 3 of you. Everybody else, you picked the Statue of Liberty? All right, I'm gonna ask for some reasons why. So you already have your reason. I just kind of want to put up here what everybody was picking. So is it SP8? How do you spell Sphinx, somebody? Yeah. And then the Statue of Liberty is good enough for me. There's only a few of you who picked the Sphinx. What was your reason? Olivia, you said you picked the Sphinx, right? Why do you say the Sphinx were most at danger and we should fix them first?
Because it would be humiliating, and I feel like that goes quicker than the Statue of Liberty becomes.
Okay, so already breaking down. Is that what you mean? Okay. I did hear one thing there. Remember, we're not talking about the actual metal part of the statue. We're talking about the base of the Statue of Liberty. Not that you did anything wrong, your explanation's still perfect, but for like going on, we're really just talking about the base. Was it you, Remy, who also said the Sphinx, or if somebody up here? Okay, so what was your reason?
Because it's been like covered already, and it's been like thousands of years, so it's already gone through most of its like finding experiences.
So really you're saying it's older and it's been hanging out longer and it's already been exposed longer and longer. So it's probably more at danger, okay? There's somebody else picked it. Who else picked you? What was your reason that you? Same thing that Olivia, it's already broken down. Okay, did anybody else pick the Sphinx? Okay, then let's hear your reasons. Let's start with you. Let's start with you. What'd you pick for your Statue of Liberty?
Because it's made.
Okay. So it's composition. What'd you pick, Jenna? Or what was your, okay. Yeah, Phoenix, what'd you say? Why would we say the Statue of Liberty, or did you pick the Sphinx?
I picked the Statue of Liberty.
And why?
Why? Because
We wrote about it, didn't you? In this big box here? What'd you write there?
so I misread the question. I thought it was asking like hanging statue, so I picked the Jesus statue in Brazil
Okay, why?
because it's big.
Okay, so what, can we apply that same thing to the Statue of Liberty? Should we say the Statue of Liberty over the Sphinx because of its size?
Yeah.
Okay. What'd you say, Drake?
I said like pollution and like people,
The-
just to like make it erode.
You think there's more pollution here? Okay. What'd you say, Landon? You picked Statue of Liberty, right? Oh, you didn't do it. Anybody else? Okay, Alex? Which one do you want to say first? Okay, and why do you think that one?
It like wiggles. Ancient every time.
Mhm. Yep. Yeah, right, but when something moves, it does create issues for breaking and needing to be fixed. It is supposed to, you're right. But it could also cause some wear and tear just by the moving. Uh, Anyway, what other, anybody else have any other reasons here? No bullying, remember, only I'm allowed to.
Not bullying, just laughing.
What other, anybody else have any other reasons, even if you didn't do this? Can you think of something why we might want to save the Sphinx or the Statue of Liberty first?
1629.
Okay, Phoenix, stay focused here, dude. So nobody's got any other reasons? So you came up with questions?
No, wait.
Oh, you got what you thought?
Well, like, from plate boundaries, you know?
Oh, okay, so which one do you think?
Probably the Sphinx. 'cause
Okay,
I think both of the Statue of Liberty is on the East Coast.
okay, but you don't know. Okay, wait, so is that a reason, or do you think that might be a question you want to investigate first?
Maybe a plate.
Yeah, because it sounds like you don't know, because I don't know off the top of my head without looking at a map at least. Chris, are you giving me a question or a big, reason you picked one or the other? Okay,
So like the Statue of Liberty, it's like made out of that thin copper, that's like that thin. So like, what if like a big old wave like comes through, like hits it over? Like, that's what's breaking right now. If it hits the Sphinx, I think it would be alright.
okay. So one thing I do want to remind you, we're not talking about the copper part. But can the waves do any damage that, I mean, it's standing in the middle of water. Will the waves be wearing it down?
Yeah.
On a side note, I know nobody said this, but is there something that's happening to the Sphinx so there's no waves there? Okay, sand and wind. Can you think of any other reason? Because the Sphinx side's a little short here, so even if you didn't pick the Sphinx, can anybody help me figure out the reason to defend we should fix the Sphinx? Okay, it's cool. Any other things? Think of that video, anything in that video that said, okay, so it's already broken down. That's one reason to absolutely fix it. It's already older, another reason to fix it. There's lots of sand and wind there. It could be wearing down faster. Can anybody think of any other reason the Sphinx to defend? Let's fix the Sphinx. Yeah. Okay, it's missing a nose. I think it's already broken down. That's already missing a nose. No, you're right though. Okay, it's already broken down.
Yeah, mostly.
I thought it was like, didn't someone like damage it?
Somebody did damage it, they said. So it appears that it said a Muslim person damaged it because they, at that time, were full believers in not offering the Sphinx. Like the people were honoring the Sphinx too much. And so he was mad at people in general, so he ruined the shrine, basically, is I think what they were saying. Again, I'm no expert in religions by any means, so that was what I interpreted that as. At the time, the Muslims were in charge and they were mad at other people, so. What else? Anybody have any other reasons to save one or the other first? Okay, so I'd say we're pretty darn split here. Some of you are it did seem more people wanted to save the Statue of Liberty, which is bizarre because my last class, not a single person picked the Sphinx. Or I'm sorry, not a single person picked the Statue of Liberty. Every single person picked the Sphinx were more in danger. So my classes so far are pretty darn split. So we clearly need to answer a few more questions before we can give our money to this project, so before we can submit our final paperwork. So there's some stuff we need to kind of research or know before we can decide which one to save. And that's where your questions came in. Yesterday, I said one good question that we clearly need to make sure we understand is what they're made out of. We already know about rocks and minerals, that some are stronger and some are weaker than others. So we did need to know what those statues were made out of. On this Post-it note, on the back, I'd like your name. On the front, I would like a question that you think we absolutely need to answer before we put any money where our mouth is here. So in the back is just your name, on the front is a question, so this was a homework assignment, so you can pick one of your questions you wrote down. If you've got the 3 questions there, pick one that you think we absolutely need to have answered. If one of your, you think this question that's already there was the most important one, go with that. But even if you didn't do your homework, I want you coming up with one question. Oh, pass them back to Stan, that's what you got to do. Even if you didn't do your homework, I want to see a question on your Post-it note that you think should be answered before we put our money where our mouth is and fix the Sphinx or the Statue of Liberty. We need all the information. What's something you think we need to know before we can go ahead and get started? Okay?
Which is,
Yeah.
do I like get a new daughter?
Yep.
Voting is very good.
These are great questions. Question that you need answered before you can decide officially.
What questions do you want to read? Let's take the vote.
I think we're not allowed to do that. I think it's in the school code of conduct. So again, what do we need to know before we can officially say which one we should fix? One example was, what are they made out of? If something's more delicate than something else, then that one's probably more at risk. What else would you want to know before we went ahead and put our money down to fix the Sphinx or the Statue of Liberty? All right, if you're not done, can you bring up your Post-it note when you are done, please? And we're gonna go ahead and get started with this research. So like I said yesterday, we're gonna come back to these pages in the back of the packet periodically, but now we're gonna go like normal and go to the front of the packet here. And we're just gonna take some notes about this chapter, weathering, erosion, and deposition. So we're starting off with, I think a lot of you have heard the words weathering, erosion, and deposition. You've heard them. I do think you've heard them. I'm curious if you know exactly what they mean. And one thing I'll say is no, I'm not actually gonna say yet. Does anybody know what weathering, erosion, or deposition is? Give me one, Alex. It is. What do you got, Trenton?
Basically like digging sediment, rocks, to form bridge or canyon.
Okay, so going on what Alex said, it's kind of like the digging. Okay, you've got a good idea of what it is. Yeah, Chris?
Ain't deposition like a river taking the rocks and all that, like downstream, like carrying like large portions of like dirt and all that, you know?
Kind of, but you have a few concepts, I think, couple vocab words that are tricking you up. But you're not wrong. Anybody else? Yeah, Sam.
Like the weathering part, like the rain and the wind breaking down bigger particles in the smaller ones.
So weathering, the rain and the wind breaking down particles into smaller ones, yeah. So here's one thing that I have definitely learned over the past 15 years of teaching this. You guys have an idea of what weathering, erosion, and deposition is. In fact, Chris's answer really had almost all 3 definitions mixed together. So he's got an idea of what weathering, erosion, and deposition is. And up until this year, I think in your past science years, those words have been used almost interchangeably, but if not interchangeably, they've always been used together. Like your teacher might have said weathering and erosion. And it talked about two things together. They weren't wrong by doing that, because I'll tell you, when weathering happens, erosion happens, and yes, deposition will be happening to those sediments. So when one happens, the other two are going to happen very soon afterwards. But this year, I do need you to separate those three concepts in your brain into three distinct things. Weathering, erosion, and deposition are three separate processes that do three separate things, and you do need to have them completely separated in your brain. Yeah. They kind of, but they can switch around a little bit too. So yes, most of the time it goes weathering, then erosion, then deposition, but they can kind of go, okay, it's been weathered, it's been eroded, now it might get weathered more and then deposited. So yes, kind of, but not always. So Sam was 100% correct with his definition of weathering. Weathering is the breaking down of rocks into smaller pieces. What do you think, knowing that's weathering, going on what Trenton said about the digging of holes? Well, how could we define that in kind of easier to think about terms? If weathering breaks down the rocks into smaller pieces, what do we think erosion does? You want to alter your definition?
Flowing and rushing water, weather the rocks and sediments under, breaking it apart.
No, he's right. So the river will weather it, it'll break down the rocks, then what will erosion do?
Clear out smaller part.
Yeah, so weathering breaks the rocks. Erosion's gonna clear them out. Anybody have a easier to think about term of clearing out? Just a regular word?
Wash away.
Wash away, move them. That's what I say. Weathering breaks, erosion moves, and going back to your deposition. What do we think deposition does? If weathering breaks, erosion moves, what do you think deposition does to the sediments? Settles them, drops them off, leaves them somewhere else. So we're gonna get those three definitions into our notes. We're gonna start today specifically with weathering. So right at the top of your packet here, we are going to get the definition of weathering into our notes. Hang on, I did this slightly differently. Here is weathering, right at the very top of your packet, please. Weathering is the breakdown of rocks into smaller particles. How do you think nature can break down rocks into smaller particles? What has the force to break rocks? Water. How can water break rocks? Okay, what does fast moving water do to a rock? It slams. That's a good word. Now, what slams, the water or the rock? The water slams into a rock? Is that what you're saying? Yeah. Yeah, ever seen a pressure washer break stuff?
Yeah.
Ever put a pressure washer on your foot?
Yeah, that's true.
Okay, don't do that. Yeah, it could hurt. Pressure washers, water can have enough force in itself to break a rock, but what else can water do, like in a stream, that could cause rocks to break? It can smooth it. How can water smooth a rock though? There we go. Say it again. No, Phoenix. Phoenix, I really need you to focus. What's it? Robert, get out of here. Say it again. What did you say? Makes one rock grind against another rock. Sometimes rivers are moving fast enough where they can push one rock around. When one rock bangs into another rock, and of course I put away all my rocks, but what happens if you take two rocks and bang them together? They're gonna break, even just little tiny pieces. If I break and I make some pile of dirt on my table, a desk, that's breaking down a rock. So rocks grinding or bumping into each other can break a rock. Any idea other things in nature that can break rocks? Yeah, people, animals, and our machinery can absolutely break rocks. Yeah, temperature can absolutely have an effect.
Like you throw a rock in a fire and.
Yep, so if it was to get really hot, we could break some rocks. What happens with really cold temperatures?
Well, usually.
They do get more brittle, okay? That's one thing, we'll get to that then. Is there anything else you can think of that can break down rocks? You said that already.
Yeah.
Can't think of any off the top of your head? Okay, how can that break? Sand and wind. Yeah, you ever heard of sand blasting? No? You have? Okay, how about in, I don't know what class that would be, somewhere, not in my realm of expertise. Like it'd be sandblast metal. Any of you people down in the shops do that? It's not welding, it's you take.
Same doesn't, but it's hungry.
Yeah, it's basically a lot like, if I understand it correctly, it's kind of like pressure washing, except for instead of water, you have air and sand. It's like high-powered sandpaper. And what does sandpaper do to things? Breaks them down, sands off some rough edges. Absolutely. In deserts or beaches where there's lots of sand or loose particles, the wind will blow them around. They'll bang into rocks enough where they'll slowly wear them down like sandpaper. Excellent. Can you think of anything else?
Snow.
What about snow? There's something about snow and ice that can break rocks. Yes. What happens to water when it freezes, guys? It expands, actually it gets less dense. Remember, water is the only thing that gets less dense when it freezes. Ever put a full water bottle in the freezer? What happens? So depending on the water bottle, it could absolutely break. This one probably, yeah, that's why they have all these. Oh, you're the first person ever to bring that up in 15 years. It's one thing I always do. There's a reason they sell water bottles like this, or the one that Remy has all those ridges on it, is because the company expects that this could get frozen at some point in its, like, between when it left the factory and when it gets to your house. They don't want their product leaking all over the place, so they provide a little bit of extra plastic in the bottle so that when it does freeze and expand, it won't break. Unlike if you were to take some other water bottles, like if you were to put a glass bottle in the freezer, or those hard Nalgene bottles that don't have much extra plastic, if you were to put those in the freezer, they very well could break. Yeah. Well, then now you know. So let's keep going so we don't get too far behind here. So there's actually two types of weathering, and one is called physical and one is called chemical. That goes right where it says types of weathering. We have physical weathering and chemical weathering. I believe it was your 8th grade science year. It could have been your 6th grade science year. You learned about chemical changes and physical changes. Anybody remember the difference between the two?
8th grade was Newton Law.
Okay, so 8th grade might be a little sketchy for a few of you. What's a physical change? Yeah, Alex was first.
Something breaking.
When something literally just breaks, we change its physical size, its physical shape. So who remembers what a chemical change is? Go ahead.
Reaction change.
Yes, so a chemical change is when the chemical composition actually changes. So you've learned, so I know you know, or we're taught that at one point. It's okay if you didn't remember it because we're gonna write it down right now. So today we're just gonna focus on physical weathering. So in that box, see where you've got, or it's not a box, see where there's one big, so you can kind of see mine here, one big rock next to 4 small rocks. These are where these notes are gonna go, right here for physical weathering. So just right below where we were writing. Just like Trenton just said, physical weathering, just like physical changes, do not change the composition of the rock. Still made out of the same stuff. It happens everywhere, but it happens most in cold, moist climates. You ever been somewhere that has what would be considered a cold and moist climate? No, Florida, cold, moist, huh? Yeah, because that's what I tell people when I'm going to Florida. I'm going somewhere cold.
Not here.
Probably here. We have a really good environment for this type of weathering. Yes, we can be warm, but we do have what would be considered a colder climate, and we have plenty of water. I have one thing to make sure you got there was this last bullet here. It says rocks are exactly the same, just smaller. Then how many of you didn't bother to write this last bullet here? If you didn't write this, I need you to include this. When the rocks get smaller, it creates more surface area. How does something getting smaller create more surface area? When something breaks, how does it create more surface area? You want to give it a shot? Yes. So first of all, let's make sure you understand surface area. If you have your hands like this together, what's the surface area? How would you tell a kindergartner what surface area means of your hand? Okay, it's the stuff on the outside, right? The stuff exposed to the air. So in this case, it's like the outsides of my hands or the back side of my hands, the in between my fingers right here where they're exposed to the air. Now I break the rocks. So I broke my hands apart. The palms of my hands used to be on the inside. Now they're exposed. That created more surface area. Rocks do the same thing. So you have that picture right there next to where you just wrote. Oops. You have this picture right here. This is one rock that got broken up into 4 pieces. So you can see that there's more outsides of the rock now. What used to be on the inside is now exposed. Think of this like a hard candy. If you were just to put the hard candy in your mouth and leave it there, how long does it take for that hard candy to dissolve? Quite some time. Yeah, I like that answer. Which is why, what do most of us do because we don't have the patience?
Bring it.
We break it. Now, I'm not talking about full-blown chewing it and swallowing it, but we at least might crack it or chew it a couple times to make a bunch of smaller pieces. Those smaller pieces, they should dissolve faster than the whole one, right? And that's because there's more outside to dissolve with your saliva. So when you break a rock, it actually makes more surface area. All right, so we already talked about a few examples of physical weathering. We actually did examples of weathering in general, and you guys all picked physical examples that you were talking about. So the first one goes along with that water freezing, and it's called frost wedging. So you have a box there that's kind of got a picture of this. So frost wedging, this occurs in climates with freezing and thawing temperatures. The best example of this is a pothole. So go ahead and put this down in the frost wedging box. Who thought potholes were created by plows? Cars in general, you thought they would just broke the ground? That's not 100% wrong. They could crack. The weight of a plow is pretty heavy. It's got sharp edges. Cars are pretty heavy. What happens with frost wedging? You want to give it a whirl? Okay, go for it. That's literally exactly how I describe it every time. You got a crack, like the crack that might already be here. Now, how the crack got there, there's lots of ways a crack could get there. It could have been poor construction in the first place. Yeah, a plow could have cracked it. It could have lots of things. A crack is there. Water gets in that crack. So water fills in the crack. What happens when that water freezes? We already talked about it with the water bottle. It expands. Now what happened to the crack? It's bigger. So what happens the next time water gets in it? The same thing, except for now the crack was already bigger, so more water gets in it, freezes, expands again, and voila, the crack is even bigger. So to add to this, let's add pretty much what Trent just said. Water gets in a crack. Water gets in a crack. It freezes, expands, and the crack gets bigger. The thing is, around here, how often does it go from freezing or thawing to freezing to thawing to freezing to thawing to freezing? Only one time a year? You sure about that?
So
even-
every other day, every other day.
I see actual water over there on the sidewalk. I don't see too much water here, but there's unfrozen water over there. It's during the day. What is probably going to happen to that water later tonight? You're right, it could evaporate. You're not wrong, it could evaporate. But if it doesn't evaporate, it's gonna freeze again tonight. And then it's probably gonna thaw again tomorrow. And then freeze again tomorrow night. And then thaw and freeze and thaw and freeze. But it might not, because we do things like add salt that changes the temperature things freeze and thaw at. Just Phoenix, please keep your hands to yourself, okay, dude?
Noises.
So this happens over and over around here. That is one reason Genesee Road looks as bad as it does. How come we have more damage from frost wedging than places in Alaska? No, they didn't adapt to it.
Not a lot of roads.
You're right there. But what about the roads they do have? We have more damage from frost wedging than they do. Because of what? What do you mean? It's consistently cold in Alaska. So like Phoenix said, in Alaska, once it's frozen, it's pretty much frozen in Alaska. It might thaw a couple times. Yes, but we're getting it almost daily. Freeze thaw, freeze thaw, freeze thaw. Why do we have more damage from frost wedging than they do in Florida? Okay, because Florida doesn't freeze too often. You're right. But do they froze? Every once in a while they froze, yes. Root action. Can you gather from the picture and the name here what root action is? Roots go down and break the ground. So first of all, I called it root action. Also add the word pry, P-R-Y, because it's also called root pry or root action. And it's literally exactly what it looks like. Roots go into a crack. They're fine when they're baby roots, but roots don't stay baby very long. So the roots grow into and under rocks. The roots pry apart the rock. Like, can you think of all those? I don't know about around your house, but at my house, we've got lots of maple trees. And those helicopters come down, and then there's a bunch of baby maple trees all the time around my house. You guys ever seen one of those? Okay, we gotta pull them out of our gutters. Little baby maple trees are growing in our gutter often. You pull them out and they have little tiny roots, not much thicker than my hair. Do maple roots stay that small? No, maple roots can be gigantic. They could be bigger than that. There are some roots on maple trees that are the size of other trees, which is not good if it had gone through your sidewalk. Here's an example. Did everybody get this written down? Here's a picture of that. Here, I don't know if it's a maple, but the concept still works. When this was a baby tree, it was fine. The roots might have only been the size of your hair, but they didn't stay that size. They grew and they grew. You can even see it popping up here. What'd you say? Definitely an old sidewalk. Does not happen after a year or two. Yeah.
I definitely wanted, it's actually a view near my house, and also like basically you can go down any sidewalk and I can believe at least once or twice you'll find something.
Yes, I was even gonna say, so it's not just Tugawanda, it's any older village. So I would assume on some roads in Arcade and Delavan, the sidewalks look like this. I know some side streets where I live look like this. Maybe not quite this bad, but have you ever been to one where it just like bumps up and down? You rode your bike over that, didn't you?
Yeah.
Oh, I was gonna say you got some air and you thought you were Evel Knievel, didn't you? Okay, yeah. I mean, I totally did that, but you didn't make it over. So anyway, yeah. If this is doing this to the sidewalk, what do you think it's doing to, I'm assuming this is a house. Yeah, it's doing the same thing to this house. The foundation, the pipes are definitely getting the same situation.
One corner of the house is just.
Let's get one more at least in there. This is actually, Trenton already explained this. I don't even have to. Just a vocab word for when Trenton was talking about the rocks grinding against each other. I use the phrase bumping and rubbing. He said grinding. We can, however you want to think of it. It's when one rock hits another rock, it's going to start breaking it. It's officially called abrasion.
Like bumper car.
It is a lot like bumper cars. If you've, the other thing is, I don't think bumper cars break down when you hit against each other. I think we have time for one more bullet here.
Oh, it's already.
Okay, I'm gonna put up the next slide. We'll start here next time, but the last slide is exfoliation, and this is when the surface of the rock peels off.
I remember I watched you.
See, I told you we had enough time. This is exfoliation, just like if you exfoliate your face. You are removing the top layer of dead skin. Here's a picture of the top layer of rocks being peeled away from this hillside. You guys have no homework tonight. Remember, if you're doing test corrections, they're due a week from yesterday. So next Thursday. Sienna, that was your third time being tardy, so you are getting written up.
Should we not? I want you here
What period are you coming down?
right now.
Right now? Yeah.
Okay.
Well, no, you just need to take the test. Here. I don't care what you get. There's a pen right there. No, just literally circle answers. You. What period did you say? 9?
This week. If, say there's like a beach, right?
Mm-hmm.
What heat would it take to turn like the whole entire beach into glass?
Like whatever temperature rocks melt at.
No, so what if
really
I
hot.
set off like a nuke?
Yeah, that would do it.
Like a
Yeah, that'll
good
do it.
20 miles away.
Yeah, that, I don't know distance, but yeah.
Alright.
You would need something like that,
Okay.
like lightning does it, but it would have to strike right there. Watch the movie Sweet Home Alabama. Nice job, 110.
Sweet.
Did I draw my test this year?